Up next, our speaker here is Nathan Vonnahme, Senior Software Engineer at Banner Health. Go ahead and give him a big round of applause.
Hey. Thanks. I'm hoping my voice will last. I'm fighting a cold that one of my kids gave me on Saturday. So I feel actually pretty good. I just sound terrible. So, and if you don't shake my hand, I won't be offended. I'm trying to make sure to wash my hands and do all that stuff. So, hi. I'm from Fairbanks, Alaska. It's a town of about 100,000 people in the middle of Alaska in the interior. And as I was getting ready, and I was realizing, going to other talks here and realizing that people come here from all over the place with so many different backgrounds. Some people are doing like real cloud stuff. Some people are doing, giant enterprise applications. I'm actually from a pretty small environment. I work at a hospital in Fairbanks. We've got 150 beds. We're the only hospital in half of Alaska, so it's important. It's 24/7 in a way that only healthcare is, but it's not enormous. And we're part of a bigger organization that operates hospitals in several of the western states, especially Arizona, and that's Banner Health. But we've got, you can read all the statistics. We have about 300 production servers. It's really hard to get an actual count, I found. About 3/4 are VMware servers. We have 361 VMware hosts, but I don't think very many of those are production, and a lot of them are desktops. So anyway, it's hard to nail that down. We have at least 400 apps. At least somebody calls it an app. And servers and apps run from, the giant mission critical thing that's on huge redundant Unix hardware, heavy metal with all the users in the hospital using it, to, something that one person uses for a billing pipeline that runs on their desktop. What else? We've been using Nagios since 2006, and I introduced Nagios because I could without a purchase order. Nagios Core, and I just did it. Actually, my coworker was on vacation, and he left me his checklist of all the things that he checks every day, and I was like, I'm not doing that. So I set up Nagios to do his checklist, and it's just, it's grown from there. In general, everyone thinks that their own software or their own vendor provides decent monitoring for their system. So I'm not going to argue with them. We just kind of, when there's an opportunity that Nagios could do it better, I say, we could do it this way and it would work. And so we've kind of grown over the years. And recently we've been starting with Nagios XI. Last year, I came and did a presentation here. And my presentation was called Monitoring and Test-Driven Development. And my coworker gave me this sample video of test driving a monitor. That was the best part of my presentation last year, and you just got it. The main meaning of the presentation last year is that I realized that monitoring tools are to the sysadmin what testing tools are to the developer. And so I tried to think, based on that central idea, I tried to flesh out what some of the developments in test-driven programming, test-driven development, extreme programming have taught the software development world, and tried to apply them to our situation. And I drew some conclusions. One of my conclusions, this was one of my slides from last year, is that Nagios is really good at kind of the unit test level of system monitoring. It can tell that your disk isn't full and your machine pings. It does pretty well, actually, at integration testing that thing A can get to thing B, and that the service dependencies are working and things like that. But user acceptance testing is maybe a weak area. That's something that Nagios hasn't traditionally, out of the box, done very much of. maybe a little bit with check HTTP. I also talked about Nagios not being a continuous integration tool. We don't, in our environment, we hardly build any software. I write software. I'm the only one who's kind of really writing a little bit of software, and most of the time we're buying things for billions of dollars and then trying to make them work. So Nagios has, it's not like you're monitoring your own code. And Nagios has strengths for that, actually. We also talked about the quality assurance idea came actually out of manufacturing before it was a software thing. And one thing that's important in the quality assurance field is testing the end product, not just the beginning of the assembly line, but all the different points on the assembly line, and especially the end. You don't want to neglect the end product. So my presentation this year is just exploring the front end, the finished product. And the main idea this year is, can users actually use the finished product of your, whatever your IT service is, and does it suck? Those two things are availability and performance. So availability is important. If even if all your checks are passing, your database is up, your disk isn't full, and your server can ping, and your other server can ping, and your network is up, whatever, is your monitoring coverage proving that the user can use the system? Is it really available, even though all the things are green? And the second question, does it suck? Anybody know who this performer is? Famous bassist? Les Claypool? Yeah, and all Primus, yeah, but all Primus fans say Primus sucks. That's like their bumper sticker. That's their motto. Anyway, does the performance suck? The user doesn't care why it sucks. It could be the light show. It could be the bass playing. It could be the sound. It could be the person standing in front of them. But they don't care why. There are lots of reasons why something can suck. And it actually turns out that sucky software makes a difference in people's lives, a negative difference. Joel Spolsky writes about software, and in one of his essays on usability, he talks about what the difference between a good day and a bad day is. And one of his early jobs was baking bread. And he learned after a while that the difference between a good day and a bad day wasn't any one major event, but it was whether a series of small things went well or went badly, or whether there were little obstacles in the way, or whether he was in the flow. And when the software your users are using sucks, they can't get in the flow, they can't stay in the flow, they have a bad day, they get unhappy. In my industry, they're asking all the patients now, would you recommend this hospital to all your friends? And was it quiet? And was everyone nice to you? And they're actually, because of the healthcare reform, everything, both parties can agree that healthcare needs reform, so things happen. All those scores become public in a couple of years, and so consumers are going to be able to go look and see, well, this hospital gets bad scores, and it's because the nurses are mean, because the IT sucks. Well, they maybe won't have that much detail, but it could happen. So anyone know why this user is angry? No. Okay. So I'm going to look at two examples of where this thinking has driven me. Recently, I'm going to show how you can do front-end monitoring on an old Windows app, our main electronic medical record software, and a cooler, modern, AJAX-enabled website. Okay, so first, the legacy one. We use the Cerner electronic medical record software, and there's no real patient information here. If you're worried about privacy, Yeah, no, that's not actually a real user's or real patient's name. Cerner is implemented with a very complex architecture. One of the earlier presentations talked about a movement in the industry away from complex monolithic systems to independent services, so that you don't have, a change in one part of the complex system taking the whole thing down. So just to give you an example of some of the layers, we have a storage network that hosts the data for that AIX, the operating system, runs the Oracle database off of the SAN network. And then the Cerner middleware, all mostly Java, runs on top of that. Then we have another SAN with our VMware infrastructure, and we have all these Windows servers running Citrix. The front end of the web, or the front end of Cerner runs on the Citrix boxes, connects back to the middleware on the back end. Around everything there's the network, and then we have the desktops actually like on the nursing floors that run the Citrix client. And there's two of everything, because we want it to be up all the time. But it gets a little bit complex. Okay, how many people already know what Citrix is? Okay, good. I'm not going to explain it. Oh, except I don't know if anybody but us uses the term fat client. That's the opposite of a thin client. Okay. So we have this complex support team. For each of those layers, there's a person or a team. And when you have a performance problem, for example, because the user says, this sucks, everybody is familiar with their own thing, and they think it's somebody else's problem. And all of our monitoring and all of our, our performance metrics, everything, are so independent that we don't always have full ownership of everything. Certain things end up being lost and found, and nobody wants to pick them up. One of my coworkers actually just quit this summer, and he moved to Minneapolis, and he got a job working for Park Nicolette for more money. Funny thing. So nobody wants to pick up Citrix because he was doing Citrix before. Anyway, he doesn't want to either. We also have these other systems doing monitoring. It's all spread out. So I thought, well, let's monitor it like a user. Let's use AutoIt to log into Cerner, search for a patient, and open the patient's chart. And we're going to do it in production, because that's how we roll. Because also, how else are you going to measure your performance if you're not measuring it in production? That's, yeah. Okay, so I'm going to show you now. Hopefully, I've got my wire here to ensure that this works. Here we go. This is what the user does. We go to, we'll open this one. We have multiple versions of PowerChart, the main application. So the user, why am I getting a Windows login? That should not ever happen. Let's let's try again. Oh, there we go. Much better. My password will expire. No. See, I wanted to really do it for real, because there's nothing like using your enterprise application in front of a bunch of friendly people. Okay, I'm logging in as a service account. Okay, so this is called the organizer. Normally, if I were a real user, I would have a list of patients there, but I didn't want to show you any patients, except, so I'm searching, and I'm going to pick one of these test patients from this month, and I'm going to say what I am. I'm a primary nurse. So, this is the patient's chart. There, the different data. This, as a test patient, this patient doesn't have everything filled in, but this is where you would go to enter or view, medical information, blood pressure, lab results.
In your production database?
Yes. Yes. Which is a good thing, because my script is going to just search for the test patient and open the test patient over and over again. So it's convenient that we have a test patient, because we don't have to actually look up a real user, which would be, I think, worse. Okay. So that's what it looks like for a real user. Let me show you the AutoWit script I wrote, compiled it to an executable, and that means that I could push it out to multiple machines without installing AutoWit or whatever. It takes 3 arguments. The first is, I can't select. The first is whether to use a FAT client or Citrix client. The second is the warning thresholds, and the third is the critical thresholds. So let's look at that running. So we'll run the FAT client with no thresholds, and it'll log in. Just AutoWit simulates mouse. Whoa, what happened? No, that's not good. Don't open the start menu. Yeah, who will watch the watchers? I've got an hourglass. That's pretty great. Only in the real live demo. No. Let's see that again. So in this case, it returned critical. Actually, see, that was good, because it showed a failure. No patient search window even after 30 seconds. It timed out and gave up and killed everything. So we'll try it again, see if it works. I think somehow my Mac sent it open the start window command somehow. Not sure. Okay. Boom. We search for the patient. We open the patient chart. Now we close everything down. Boom. We're done. And we get the performance data here. The initial login took 0.92 seconds, and so on. And that will be important later. I'll show you the graphs that we can get out of that. In the interest of time, I'm just going to give you a quick look at the script itself. And does anyone else here use Cerner? Okay, you're lucky. It's all pretty straightforward stuff. Parsing arguments is a little bit convoluted in AutoWit because it's kind of rather limited. It's a VB script-like language. Basically, we give the operating system a command to run to launch the process, and then we start timing how long each step takes, and collecting them to print out the performance data at the end. I have mostly used keyboard shortcuts for all the navigation, like opening the search form, because then the screen resolution and everything doesn't change. When you use mouse events, Sam's presentation right before this was talking about AutoWit, and just when you use mouse events, if something changes with your resolution, then your mouse can get all off kilter, and you can be clicking in the wrong spot. And it's most, especially old Windows applications like PowerChart, are easy to script with just the keyboard. So then the important thing for Nagios is the exit code, and whether it's OK, unknown, critical, or warning. Sam wrote a couple good articles this summer that are on nagios.com about using AutoIt, and he did a presentation right before this one about that, and eventually the video of that one, if you weren't here for the last presentation, you'll be able to look at that video. In my Nagios Client++ configuration, I just defined my check scripts with my thresholds built in. You could also set it up to pass it from the Nagios server. It just depends on where you want to configure those thresholds. There were several gotchas when I started actually running this for real, and I'll go through them quickly for those of you. I know Sam is going to be looking at this stuff later. One that I found is that if one script failed or hung, then the other one would conflict with it, like if there were two power charts up at the same time. So it runs a routine at the beginning to just kill everything. I found AutoIt has a feature that will let it, it's kind of a hokey callback thing where you can tell it, basically you set up an ad-lib function that will run every quarter second until you unregister it again. And you can use that for handling the weird little pop-ups like your password's going to expire in 10 days. Is that okay? And so you can have conditional code. One of my problems was putting stuff in the wrong section of the INI file. Look out for that. If you're like me, it'll happen to you too. Oh, I found a magic checkbox. We affectionately call checkboxes like this the suck checkbox, or the suck box. This one is actually kind of makes sense, but you know, some cases it's like suck, you know. And if that checkbox is checked, then everything sucks. In this case, you want it to be checked in order to allow the service, because NS Client++ runs as a service, to let that interact with the GUI environment, the user's environment. You need that? Oh yeah, that was in Sam's, that was in your thing, right? It was in your document. Yeah. And then I found that AutoIt by default, for some reason, it doesn't send output to standard out. So NS Client++ doesn't want to talk to it. And in Sam's document, he worked around it by having it open Notepad and type stuff into Notepad and save the file, and then gave the file to NS Client++. But I found that if you compile it to an exe and you check this checkbox, then it will actually send its output to the console, and you can run it on the console, like in that example. No, like in this example, where it actually outputs on the command line, which is what you want a Nagios plugin generally to do. You can also use the command line version of the compiler rather than this GUI, and then you just give it the /console option. Another thing I found was that Windows applications, have you seen this one? If the Windows application closes before it sends the free message to its tray icon, the tray icon stays there, but as soon as you put your mouse over it, it disappears. And I accumulated dozens of these, because both AutoIt and PowerChart would leave their icon there. And it actually was slowing my virtual machine to a crawl because there were so many. And I found a utility that somebody wrote that runs every 8 seconds or something and just clears them all out. OK, so here's the interesting part, the graphs. I ran this for a week, except for when it was broken. See, I had this idea months ago, but it was the deadline of the conference that made me actually put it in production. So that's a good thing sometimes. So this is a week of 15-minute samples of it running every 15 minutes. We've got a different timer for the initial login, for the organizer screen, and for the opening a patient chart. Now, so this is the Citrix version of the client, and we noticed that normally, well, the average time is listed right here as 9.5 seconds for the login, but then only 2.8 seconds average for the organizer. And then there are spikes that go well above that. The FAT client has a much different y-axis. And these are just the default RRD graphs from Nagios XI. I didn't cook them in any way, so I guess it would be interesting to compare them with the same y-axis, but this one is all close to 1 second, and the average is 1 second. And the maximum, the highest spikes on this one, only go up to 3 seconds, whereas the other one cruised along at 9 seconds. So that shows you the vastly different scale of these graphs. When we put them next to each other, we can see that the login process is especially painful in Citrix. And this is the Citrix version is what we actually deliver to our users. And we're not going to stop using Citrix. Like almost all Cerner clients use Citrix, and there are lots of good reasons for it. But we have a problem here. And comparing it to the FAT client really highlights that problem. The average time, average time of 1 second versus average time of over 9 seconds, almost 10 seconds, is just pathetic. When we look at opening a particular patient's chart, we see that the performance is much more similar between the Citrix client and the FAT client. But even that gives us some useful information because we see that, for example, most of the time it's pretty steady. It's around 2 seconds here, really around 2 seconds here. But there are these large spikes, and they were at different periods on Thursday. We're only sampling every 15 minutes, so it's possible that we could be missing shorter performance events where the system slows to a crawl because of some big process or something. But I think that this implies that there was some sort of a back-end issue, especially on Thursday. And that is important too, because that kind of takes the whole front half of the application out of the list of likely suspects. But we are looking at some wait times here of up to 15 seconds or 8 seconds just to open a patient chart. And you better believe that the users noticed those things. So by just doing this, just for this week, well, it's been 3 weeks now. We've got several advantages. We've got continuous monitoring of our end product, which we didn't really have before. We can hook up the Nagios whole flexible alerting and escalating event handling, whatever we want, we can do with that. We also have the ability to do control group and experiment group because we have the baseline now for the performance. We can compare the Citrix and FAT client, compare changes, see the before and after. And we've actually already, in talking with the temporary Citrix people, because nobody wants to fully commit to owning Citrix, we've identified one symptomatic problem that we can actually monitor with Nagios and fix with an event handler, which Sam was also talking about earlier. So basically one service goes and uses too much. Something happens involving certain printers. And after the user with the bad printer logs in, then the Citrix print service goes up to 25% CPU utilization and just stays there. And everyone who hits that Citrix server after that gets horrible performance. So we're using a WMI check to check for that process's CPU utilization, and using an event handler to restart the service, to run a batch file that shuts down that and restarts it. We haven't been able to catch that one in real life yet. We can't duplicate the problem, but we've got the event handler running on a couple of hosts, and I was hoping to have a wild success to report this week, but we just put it on 2 production hosts on Monday, so I haven't got that far with it. There's still more to do. I realized, oh yeah? We've got a question. I realized actually when preparing for the talk that I do all the work of parsing the command line arguments for the thresholds, but then I don't put them in the output. I don't change, I don't warn if it's over a certain number of seconds. So I need to do that. We can run more experiments, and that'll be interesting. Right now the Citrix servers and the virtual desktop that I'm running the AutoIt script on all run on VMware. And so if we had a VMware performance issue, it would affect all of that. So it would be good to have an out-of-band, non-VMware host running the check script to compare against the ones that do involve VMware. So a hardware desktop machine running the FAT client would give us another interesting data point to compare. Yeah, okay, and my next slide is questions. So,
well, I think that's what you're saying then is what I wanted to know is if you're running that on actual physical hardware like the NS client that's in a VM, is it? So when that check runs on that VM, that displays on the VM and everything is shown on the console of the VM?
Yes, this is actually my virtual desktop, and I just set it up on my virtual desktop. And when, let's see, do you want to see it run from the back
I'm just
end?
curious because
Yeah.
we do terminal server sessions, and we have clients that are on remote links, and my boss wants to know what the performance is like at the remote link. And we do have some transfer PCs that sit there, but a user could be using it. So if we send a check off and push, it's
Yeah.
not what they want.
Yeah,
Could you
no,
run it not to display it on and just still run it and do everything, but not display?
because it's using the Citrix client, I think it has to be logged in as a real user. Actually, when I had no open connections to my virtual desktop, even though the virtual desktop was still running, it didn't have a console running, and it stopped working. That's what that gap was when I closed the window and I wasn't connected to it. So, and yeah, it does run every 15 minutes. You get to watch just like we watched it. And so that can be, it can start typing stuff into the config file that I'm editing and things like that. So yeah, really the next thing to do is to put some real resources into it and give it its own machine and make sure it auto log-ons at boot and things like that. Any other questions? Yeah?
So,
Sam?
so the workaround you found for instead of opening the text file, do you have that available anywhere for use or?
Yeah, it's just that the console switch on the
Okay.
compiler.
Oh yeah, yep. Okay.
And yeah, I'll give you a copy of my presentation.
Okay. Cool. Thanks.
Any other questions? Ready to move into the 20th century? I mean the 21st century. Okay. Now for something more modern. This is not a fair comparison because it's so simple, and it really, yeah. But it's maybe more relevant to more people in this room. This is an application that I wrote for when Cerner is down, which is once a month at least during a maintenance window. And this application is designed to be mobile friendly, or it uses the jQuery mobile framework. It runs just fine in a browser. It allows the physician to select from our kind of menu of normal treatment options so that they can quickly select the normal orderables for a patient who presents with a certain symptom. Well, we probably don't want two of the same thing. Those are different doses of the same drug. Lab tests, whatever. And then since it's for downtime use, it makes a PDF that they can then print out and sign. And that gets entered into the system later. So the thing about it is that as a modern web app, there aren't full page loads. It's using Ajax to replace part of the page, which means that some of the conventional approaches to monitoring it aren't going to necessarily work. So the questions are, how do we tell if the users can actually use this, and how can we tell if it sucks? So one option I've used in the past is back-end scripting tools like Perl. I've used the Symfony PHP framework before, and it has its own simulated browser for hitting your application. You can write functional tests. The problem is that they'll never really do JavaScript, so they can only approximate what a real browser is doing. And especially in more JavaScript-intensive modern websites, I just don't think that it cuts it anymore. Another option is Selenium, which Sam demonstrated just an hour ago. And I know other people are using it successfully. Nathan Broderick, who's here somewhere at the conference, is using it. He showed a great demo of it last year. I've never gone there. And I think I just have this image of all these browser windows like running all the time, doing all these tests, and just Firefox running out of memory and crashing and things like that. And it just doesn't seem like, I don't know. I've just never gone there. But I know that people do it, and people have huge test suites running in Selenium. But this year I found Phantom.js, which is a headless WebKit, which is just the thing. So WebKit is the HTML and JavaScript rendering engine that's used in Chrome, Safari, Android browser, and iOS browser. And between those four browsers, they've got the biggest market share of any of the layout engines right now. So the WebKit engine is, you know, a pretty standard, well-represented, full-featured browser. But Phantom.js takes all the graphical stuff out and lets you just run it from the command line. And you script it using JavaScript, and it executes the test script using its own V8 engine built into WebKit. So it's fast and good and standard and everything like that. I've been looking at JavaScript more and more lately, and two things. The first is Brendan Eich, who originally wrote JavaScript. He says, always bet on JavaScript. Everybody always, I mean, because it's kind of not very good. Everybody always predicts its downfall, but it's always easier to make it work than to replace it. And so JavaScript has made huge strides in the last 15 years that it's been around, and it's just gathering steam. And there's a huge JavaScript community, and it's really in a renaissance now, even though it's been bad for so long. Like, I always thought it was just for messing around. But the other thing, if you do start going down deeper in the JavaScript world, it's good to take some time to learn it. Douglas Crockford wrote a book about it, and he said that it's unlike any other language. People just start using it without learning, and you can get a lot further if you spend some time learning its quirks. The thing is that it looks like C or Java, but it actually is more, it's fundamentally closer to a language like Lisp or Scheme that's very function-oriented, Lambda function-oriented. It's very event-based, which is different than a functional language that many of us are used to from scripting. So it's worth spending some time learning what it is before you use it, but it's fun to use. And then somebody wrote Casper.js, which is a nicer API. It abstracts some more things on top of Phantom.js. And so, okay, enough of that. Let's look at the code. Oh, let's look at. So we start off describing our virtual screen size. And in this case, I thought, well, the iPhone 5 was just released. Let's pretend we're an iPhone 5. We start up our timestamps. We get the browser ready. We load the first page and record the time. The pattern for a lot of JavaScript things, especially Casper, is you have a function that's executed when the step is complete. So you have all these nested functions. We're going to fill in chest pain just like I did manually. Then we time the next result, the search result. Make sure there's at least one search result. We click on the first one, and we check that it has the content we expect, at least 10 check boxes, and then we try printing out a PDF or downloading a PDF anyway, and then we do Nagios exit. So let's look at that in action. Oh, that's the other one. So remember, this is not just doing one page. This is doing the initial page load and then the search. It's a 4-step process, I guess. And in this case, it was OK. And we have a total for all the steps together, and then a breakdown of how many milliseconds each step took. I was able to install this right on my Nagios XI VM, which is fun. Like, it's just right there. I don't have to fuss with NRPE or anything. It is firing up a WebKit instance, so it's kind of a little bit heavy duty. I don't know how big the process is, probably a few megs, which on a modern machine isn't that big of a deal. But if you had a whole lot of them going at once, you might want to look at a lighter weight solution. Zombie.js is a pure JavaScript browser simulator. It can run JavaScript in the client, but it doesn't have the whole WebKit engine behind it. So that might be a lighter headless browser if you are doing a lot of these checks together. And on my blog, I posted, if you just want to paste the commands into your terminal and start going, there are install instructions for Phantom.js and Casper.js. Now the graphs for this, what is this, for a week? Oh no, this is just 2 days, but it's relatively boring. The peaks and the valleys aren't very far apart. The total time varies. I guess we had a little bit slower performance, but that's, the maximum is like 1 second slower, maybe 2 seconds slower than the minimum time. And that's for the whole test, all 5 page loads, or virtual page loads, Ajax page loads. But we get many of the same benefits from front-end testing with the web app too. We get assurance that the basic function works for a user. If the user can use it, actually, all the layers are probably working, right? So we can assume a lot. And we have a benchmark so we can evaluate the end result of changes, whether we install a new version of jQuery mobile, or so on. Yeah, there's more to do. One of the things I want to do is set it up to run on an internet host. Right now, I'm running it within my data center, so that doesn't necessarily mean that an external user could get to it. So, get a host somewhere out in the cloud and run the check on it. But then that relies on that host being up, and having connectivity back to the Nagios host. So to sum up, the main idea is try to include in your monitoring plan end-user monitoring, front-end monitoring, your finished product monitoring. Ask if the users can actually use it and whether or not it sucks. All right? And Any questions? Or the code for the JavaScript examples is in gist. I didn't think anybody would want a script cerner like that, and it has some specific stuff to my environment, so I didn't make that public. But if you want to take a look at it, I'll send you bits of it. Yeah. Any other questions or comments?
Do you have any projects you're currently working on?
I do. I have one more. It's like you were leading up to my last slide. I do have I did do one other thing, which was a joke that Andreas and I were talking about at lunch last year, which was to hook Nagios up to Facebook so that it could page me if I don't have enough friends. And unfortunately, Facebook has this like privacy idea, right? And they won't just hand out how many friends I have to anybody. So it was more difficult than I first anticipated last year because of the privacy issue. But I got it to work using Node.js. And so here's an example. I give it my username. Now I have had to register as an app and give my app permissions to view my friend information, my relationship information, so it can count my friends. Because, so my Nagios plugin is now just like Farmville or another app. I'm in good company, right? So it's going to warn me if, I only have 202 friends. So anybody going to friend me quick? No? How about now? Still warning. Anyway. This could be useful. I suppose some companies maybe care about how many people are liking their company. And like if you're, that might actually be the ultimate in usability testing is if all of a sudden people start unfriending you, something might be wrong. So, or unliking, yeah. And then I'm giving a demo on Friday morning about writing custom Nagios plugins. We're going to see plugins in Perl, plugins in Node.js, and another wacky auto example. So come see that if you want more. Or I'll be around. Thanks a lot, everybody.